Hey everyone, today we are going to solve a problem that delete a node from the end of the linked list. So we are going to start a problem like this, that you have to remove the nth node from the end of the linked list. So, so in this problem, it is a type of problem which relates the topic linked list and two pointer. And after that we have what is given in the question, that we have to remove the nth node from the end of the list. Means you have given the head of the linked list. This is the head of the linked list, and this is the n, which the node we have to remove it from the end of the list. So first we understand the question, that it is a given list, and if suppose n equal to 2 has been given to you. Okay, if n equal to 2 has been given to you and this is the list, so from the back side you have to remove the second element. So this is the 1 and this is the second element, so you have to remove this. So the list will become like this: 1 2 3 5. So this is how we have to do it over here. And we look into it, that if n equal to 1 is there and if head is 1 is there, then we have to remove the first element from the end, so it will be empty list. And if one element we have to remove, we will remove this two element, this two we will remove, and the one will be the output. So this is the problem statement. And here I'm going to tell you about that. First I'm going to tell you the brute force approach, and then I'm going to tell you the optimal approach. So first approach, I would like to tell you that first approach is like this, that approach one. So in approach one, it is first approach is that what are the steps we are going to take in the first approach? That the head has been given to you and we have to remove the nth node, right? So what we have to do in this, we will first find out the length of the whole linked list. Okay, whole linked list we have to find out the length. After finding out the length, we will find the index of the node which we want to remove it. Listen carefully. We will find out the index of the node which we want to remove it. So index of the node which we want to remove it is find out by length minus n. Okay, we will find the index of the node which we want to remove it. And unless the index, we will run a loop till index. Okay, we will run a loop till index. We have find out the index, so we will run a loop till index. And while running on the loop till index, uh, we will take a node up to there. Okay, we'll take a node up to there, and after taking a node up to there, at last we will return that suppose previous we have taken over there, so previous dot next is equal to previous dot next of next, and at last we will return head. So this is the rough info about what we are going in the first approach. The time complexity of this is order of n square, and though we have a better approach from this. The better approach is that approach second, which is an optimal solution. And an optimal solution is of when we are taking two reference, current and previous. We will take a current to a node which we want to remove it, and previous will be in the head, and then we will take both forward until the current is equal to null, and then we will return the previous of next is equal to previous of next dot next. So like this, we are going in the first approach. Why it is going to take order of n square? Because order of n it will be taken finding out the length, and then finding out then removing the element in the next. So it will take order of n square. Here it will take order of n and there will be no space. So this is the better approach than the previous one. So now we are going to do this. Let me take to the program. Okay. So yes, as discussed above, we'll find the length of the linked list, which we will declare as 0. And for finding the length, which we have to declare a list node, let's say current, and current is at position head, and we will run a loop that when current is not equal to null, we'll make it current not equal to null. We will do alien length plus plus, and we will move our pointer to forward. Right, we'll move our pointer to forward. Here we have calculated the length of the linked list. Calculating the length of the linked list. Calculating the length, okay. Calculating the length. And now we have calculated the length. And now we have to calculate the index of the node which we want to remove. So if int index to remove, okay, int index to remove. How we'll find the index to remove? Suppose uh, index to remove. Suppose we have to find the index of this one. So we have calculated the length, right? The length is 5, right? And the n is given 2, right? So 5 minus 2 is equal to 3. So I think 3 is the index we want to remove. Let's see over here. 0, 1, 2, and 3. See, 3 is the index which we want to remove. So like this, we will find the index which we want to remove it. So index to remove is find by length minus n, right? So now here the edge case is that suppose that the index is 0. Suppose that length is reached to here and the index is 0. Index to remove is 0. So you want to remove the first element. Then for this we will write an edge case over there that if index to remove if index to remove is equal to 0. Okay. If index to remove is equal to 0, then what we'll do head is equal to head dot next. Head is equal to dot next, and then we'll return head. That we have to do in the first one. So this was the edge case, right? And after finding the edge case, what we have to do? Let me think. Uh, int we have find the index to remove. We have find the edge cases, and after the edge case, if it is not 0, it might be something somewhere in the middle, right? So we have to run a loop over there, right? To run a loop over there, we have to make this current at head position again. So we have to declare another pointer over there, I think. Yeah, we have to declare another pointer. Let's say previous, and previous is at null. Okay, and we have to current is at head. Okay, then they will run loop equal to 0 I less than index to remove. Okay, over there, and then what we'll do over here, up to there we will do it. Yeah, up to there, what we'll do, we'll make both pointer over there. First we will take previous to current, and then we will take current equal to current dot next. Okay, means what we have done over here, that previous will be over here, right? Let me draw it. Previous will be over here and current will be over here. Before moving the current to the forward, we have to take the previous to the current. This is what we are doing, and we will do until the current reaches to this state. Okay, so 0, 1, 2, 3 until the current reaches to this state. So finally, at the end of the loop, what will done? Current will reach to this state and previous state will reach to this state. And the end, what we'll do? Previous dot next is this and current dot next is this. We have to remove this node. So what we'll do? We will break this contact and we will make a connection over here. How we'll do that? We'll do by previous dot next is equal to current dot next. We'll make this connection by this. Okay. So what we'll do in this? So what we'll do in this? Yeah. So mm, previous dot next equals to current dot next. Okay. Previous dot next equal to current dot next. After doing this, we will return head. Okay. Let's see. Okay. All the test cases are passed. Okay. So this is done, right? So this was not a good approach. So I'm deleting this. So this was not an optimal approach to do the question. So now I'm telling you the optimal approach. Okay. So for the optimal approach, we have to make the use of a two pointer. With the help of two pointer, we will take out the head node. The removed node. How we'll do that? First, we will check the base condition that if head dot next is equal to null. If head dot next is equal to null, then we have to then we have to return the first one on null. Okay, right. Nothing. This is the base condition. If head is next, we have to return the simple that's only. Nothing we have to do. Okay. Now next what we have to do? We will create a node and we'll take the node to over here. How we will take the node till here? Let's see. 1 second. List node current equal to head. And we'll run a while loop up to where? Up to n greater than 0. Okay. And we'll make this pointer to the next. Right? And we'll do n minus minus. What will happen by this? My current pointer will reach over there. Right? My current pointer will reach over here. And now what we'll do? Now what I will do? I will create another pointer. Okay. I will create another pointer which, let's say, previous, which will be mm, head, which will be head, which will be at the head, right? And we will run this loop. Mm, okay. Let's say we are moving this current next, right? Let's say if current is at the position null, then also we have to return the first node only. So this again one condition came over here. Suppose that if current is equal to null, if current is equal to null, then also we have to return the head position over here. Okay. Okay. So this is the list node, right? So okay, we have declared a previous, right? Now what we'll do, until the current until the current is not equal to null, is not equal to null, we'll move both the pointer forward. Previous is equal to previous dot next, and current is equal to current dot next, right? And what we'll do, we will do previous dot next is equal to previous dot next dot next. After doing this, then return head with there. Okay. 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 What is the error is coming? Okay. Mm, not next. Yes. So this is the two approach. We have told that why it is current dot next, because if it is reach over here, then if suppose current is reached over here, right? Where is my pen? Current is reached over here, so its next will be not next will be run, right? So at that position, previous will be over here. So previous next is this. Previous next is this branch, and previous next dot next is this branch. So we are not connecting this. Instead of we are connecting this, and at last we'll return the head, which is this. So 1, 2, 3, 5 will be the output over here. So yeah, that's all about this question. Hope you understand it, and thank you.